All right. Okay. There we go. Hello, 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 everybody. Hi, everybody. I hope everybody's doing good this morning, or for those of you overseas, this afternoon. How is everyone today? How is everybody doing today? There you go. Hey, Brenton, my friend. Brenton, how are you, my friend? I hope you are doing really well. I hope you had a really good weekend. Any uh any plans for Thanksgiving there, Brenton? Wonderful, wonderful. All right. I know there's not a whole lot we can do here for Thanksgiving, obviously with the lockdown and all, but hopefully you'll be able to spend it with your family at the very least and have a nice meal together or whatnot. So, yeah, just staying home. Yeah, I'm gonna go visit my family too. I'll probably stay there for a couple days and then head back here. But yeah, yeah, I'm gonna go. My mom's like now like 40 minutes away, so I haven't seen her in a little bit. Um, I was gonna see her this weekend, but then my sister's like, "Yeah, why don't you just come by for Thanksgiving once it starts?" So I'm like, "Okay." We'll probably just sit down and have a nice meal together. That's probably what we're gonna be doing. Probably just chilling, talking, whatever. Yeah, it doesn't have to be like crazy. It could just be like, okay. Just sitting, chilling. Having a nice time, drinking some water or some pop or whatever. Nice, nice. We're gonna start here in a couple minutes here, Brenton. If nobody else comes by, I'll just go ahead and get going here, and then we will start. We're gonna be doing chapter 8 here today, so chapter 8 is on the agenda. That is our plan, man. We're getting there. We're getting there, by the way, Brenton. We're almost this chapters 8, 9, and 10 after finish chapter 8 here today, more than likely, and then we'll get right into chapter 9 next week. So coming down to the end of the semester already, if you can believe it. Can you believe the semester goes by so fast? I mean, holy cow, right? Yeah, I'm crossing my fingers for you too. You've been putting in a lot of hard work, Brenton. So, passing grade is certainly possible if you've been putting in the time and the effort, which it certainly sounds like you have. I know you come here to every live stream, which I super appreciate, and you ask a lot of questions and whatnot. So I mean to be fair, yeah, there's definitely a possibility to get a passing grade for sure. Like it's you just have to put in, do good on the tests and do the homework and whatnot. Homework is a lot of the score as well, so to be fair. Yeah, look, Brendan, I'm not expecting. Hey, JC, where can we look at our grades for the class? So you can look at your grades there on Blackboard, or you can look on my math lab. I don't have much update on Blackboard, so that may not be the best part there. I will have to update here during the course of the week. A lot to catch up on in that regard. But yeah, you can look up on my math lab, and that'll give you a good idea about where to find that stuff there, JC. Yeah, just take everything under. I need to just I'll need to update that. So I think I'll need to do give you a proper update on that. No worries, no worries. All right, think we're ready to go. Let's go ahead and get going here. Okay, let's get started today. Welcome back to Monday. Hopefully, a nice weekend. So today, hey, Dr. Dan, how are you doing, my dude? I hope you are doing well. I'm gonna turn down the music here just a smidge. Be kind of like floating in the background, just a smidge. In any case, all right. So let's talk about what we're going to be doing here today, everybody. Let me give you a rundown about what's going on. All right. So today, this is going to be our only class that we're going to be having this week. Remember that we are not meeting here on Wednesday. That is a Harper College holiday for Thanksgiving break. Okay, so only class this week is today. I'm doing really good. I'm doing really good, Dr. Dan. Really good. Had a really good weekend. It's been a pretty good weekend so far. Um, so just note that this is the only time we're going to be meeting this week. Now today, what we're going to be doing is we're going to be finishing. We're going to be starting and finishing chapter 8. Okay, so chapter 8 is what we're going to be doing here today in some capacity. All right, so just note here, there are 4 sections in Chapter 8, but we're only going to do 3 of them. So just as a reminder here, we are going to be skipping a section here. We're going to skip specifically, we're going to skip section 8.3. All right, so we're going to do 8.1, 8.2, and 8.4. Those are the 3 sections that we will be doing today. So 8.1, 8.2, and 8.4 will be the sections that will be done, and we will skip section 8.3. All right, now considering we'll get right down to the home stretch of the semester right after this, where this is done, as I was mentioning earlier, I have a lot of work to do on my end. Obviously, you guys have taken the test and whatnot. All right, so that, the first test anyway is what I'm referring to. So that thing's been done and dusted. And of course, an update on your homework scores. I can look at that there and give a good guesstimate of the grade there. Now the homework's open until the end of the semester technically, so you have time to finish those up. You know, closer to the end of the semester time. I would continue working them because there are a lot of assignments. So that's definitely within your best interest to go ahead and finish those ASAP. If you want to improve on those scores, you can go ahead and do so. I don't particularly mind about that. So there's that, and then once we're done with chapter 8 here today, we're gonna go right into chapter 9 and 10. which are the last two chapters of the textbook. So we're really close to the end of the class, but we're really close to the end of the book. And I expect for us to finish the end of the book probably, um, you know, either by, if not next Wednesday, then that following Monday, so the 7th of December would be that. So, by the way, keep your ears peeled out for December 10th. So keep your ears peeled out for December 10th. That hopefully will be a very good day. So December 10th is when the FDA could approve a COVID vaccine for 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 use. So that's going to be a big day there. I think that week's going to be a pretty good week. So hopefully they'll approve that vaccine on emergency orders, and maybe they'll start slowly rolling out the vaccines starting from the 10th. So ladies and gentlemen, there is definitely light at the end of the tunnel. There's hope on the horizon. So it'll be a slow roll until everybody can get a vaccine. But if it's approved, then you know, um, we're going to be in really good shape, and everybody will be in really good shape. So I don't expect this thing to end until the end of the summer, next summer, but at the very least, there is a definite path forward. So just letting you guys know, something to look forward to, definitely. All right. Okay. All right. So let's go ahead and get started here with chapter 8. And before I get started here, really quick, just asking you guys here, you guys, do you guys have any questions from last time, or any questions that you had for the class over the weekend? Any questions at all? Again, type no in the chat if you have no questions, so I can move on. So if you don't, then just type no. No. Okay. Remember, just please let me know. If you don't have questions, just say no. If you do have questions, just go ahead and type it out outright. So, no. Okay. Just stabilize my camera there. Where do you find your grade? Right now, you can rely on my math lab and the grade book on there. That'll be a pretty accurate representation of your grade. I guess there's one thing I do have to say is my math lab's a little weird about the grading process. It will give you the grade of all the assignments that you've started. So if you haven't started the assignment, it doesn't factor that into the grade. So if you want like a super accurate grade, then basically you start every assignment outside of the tests, of course. Yeah, don't start the test, obviously, but basically start every assignment, and then it'll give you an accurate grade for up to that point. My math lab is really weird like that, so I'm not sure why it decides to do things like that, but yeah, it's kind of weird. I never quite understood that myself. I have to update a lot there, Dr. Dan, so that's for sure. On my end. That's a me problem, though. That's not a you problem. Any other questions before we start? All right. No. All right. Go ahead and go to our main page here. Woo! Fade transition, ba-bam. All right, there we are. Okay. Okay, so let's go ahead and talk about Chapter 8 here today. Chapter 8 is going to be dealing with 2D figures. All right, but the first section here is going to be talking about one of the most important things when it comes to 2D shapes, whether that be on a print or otherwise stated, and that is angle measurement. All right, so this is actually going to be one of those sections that is going to be a little bit more important in chapter 10, more than it is in this section. So they kind of shoehorned it in here, but there are a couple of important points for us to know just because we do see these quite often in 2D shapes and 3D shapes and whatnot. So let's at least talk about those first and foremost. Okay. Now this section here is not very long, but what we want to talk about here today is we want to talk about in this section here, we want to talk about types of angles, and we're also going to talk about degree. We're also going to talk about degrees, minutes, and seconds. So we're going to talk about that here and some basics about angles. I guess I'll just put the basics of angles. All right. So we're not going to get super in depth about angles here, but there are a couple of mathematical points of view that we certainly want to take to the bank here. First of all, let's talk about types of angles. There are several types of angles here, many of which you are, I think, rather familiar with. Again, you probably have seen this at least once, or maybe you've used it many times. It just depends on what your background is at the end of the day. Let's talk about types of angles here first and foremost. And we'll go ahead and draw out some pictures here to make it easier. Okay, so the first angle here is probably the angle most people have seen the most of, and that is our good old friend Babam, this guy right here, which is a right angle. I think most people have seen a right angle at least once in their life, and probably used it somewhat a bit, back in the day, replay. We'll talk more about right angles here, more so in chapter 10, but right angle, as you know here, is a perfect 90 degrees. Okay, so 90-degree angle is a right angle. Good. Okay, now from this right angle, we do get two more definitions here, two more types of angles here. First one is this angle right here. All right, and so this is an acute angle. An angle here means less than 90 degrees. Okay, so any angle that's less than 90 is an acute angle. So we just basically use the right angle as kind of like our midpoint or reference, if you want to call it like that. The second angle here, let's talk about that, is this guy right here. So this angle is called an obtuse angle. So of course this is more than 90 degrees. Okay. All right. Let's also talk about a few more things. Another angle here that we can see for sure. But this angle here. So this angle here is a straight angle. The straight angle here is a straight up 180 degrees. So as you see there, half a circle. Remember that a full circle here will be like a 360 degrees. But again, we're dealing with a straight angle here. It's 180 degrees, just like so. Nothing too fancy going on there. You're like, okay, that's fine. Um, and those are the ones that probably want to focus on here for the most part. There are other types of angles here as well. So I'll just kind of briefly mention them. We do see these. We do see these, of course, sometimes, but you could have angles that are like this. So, oh, oops, wrong one. My bad. Right, draw in these. Okay, so these angles here are vertical angles. And again, we'll talk a little bit more about that when we talk about the basics here of angles. All right, and Yeah, that's probably the only one. Vertical angle, the only one I want to talk about. And right, I guess I could show this off here. So you could have like two parallel lines like this, for example. Actually, I put that the wrong way. I did do that. You could have one line here. You have two parallel lines that look like this. This is what we call a transversal. Although, I mean, it's like, okay. I'm not going to get too much into it. What I do want to focus on is more of the basics about angles that we'll need to use. All right. So types of angles there that we can see the first photos. Am I able to post this in my notes? That's a good question. Let's see if I'm able to copy this. And copy. Let's go into my thing. Yeah, yeah, there we go. That works. All right. Done and done. All right. See, look at that. It worked out, Brenton. Hey. All right. Let's talk about basics of angles here. Yeah, I'm willing to work. We're willing to work for it. No problem. All right. So let's talk about basics of angles here. So we got these angles up top. We got our types of angles here. Of course, a couple of things that we need to know about angles that is going to be very important. Number one is talking about a triangle. All right. So if we have a triangle here, and I'm going to go ahead and erase this here. Let's check. Okay, that didn't erase that. Good. All right. So the next thing is about, let's first talk about triangles. Okay, so if we have a triangle in general, where is Mr. the Triangle? There you are. Okay, so here's a basic triangle that looks like this. Okay, not not overly too hard, but if we want to add all the angles inside of the triangle here, so let's say we have this is an angle, this is a second angle, and this is a third angle. Okay, these all could be different here. Obviously, this is a nice triangle, but these could all be different, all right, for all we know. But let's see if you guys remember here. If we add all the angles together, what would that equal? Anybody remember? All right, very good. That's right. Sum of all the angles here is exactly equal to 180 degrees. That is correct. Very nice. All right, so that's one thing you can take to the bank here. Even if they're all different, you know at the end of the day that's going to be equal to 180. Now, that's going to be kind of that's going to be important here a little bit in this section, but it'll be definitely more important here once we get to chapter 10, talking about basic trigonometry. So when we talk about that that's going to play a bigger and more important role. But here we're just talking about the basics, so nothing too crazy. A couple of things here regarding basics of angles that we do need to discuss is, of course, talk about one definition here. The first definition that I guess I want to talk about here specifically is talk about, let's see here. Let's talk about congruence. Okay. Congruence is when two angles are the same. Okay. When two angles are the same but are in different spots. All right. So we say two angles are congruent, for example. So if we have a vertical angle here, let's go over our previous example here. So I showed off a vertical angle in the last picture there. Okay, like this angle here and this angle here. Now these angles here are exactly the same. So let's call this angle A and angle B. You can say A and B are congruent. So A and B are congruent, and that's how we essentially get that. So we could say like, okay, if B is like 30, then the other one is 30 as well. Excuse me. All right. So we're talk about congruency there. That's fine. Now I do want to look at an example here. And let's take a look at an example. Go ahead and crop this out. All right. Guess I don't need this. All right. Now I want to look at an example here in the book. Let's go ahead and take a look at that. Okay. All right. So really quick here is I want to look at letter A, specifically letter A here. All right. So if we take a look at letter A, can anybody tell me here, what do we get for angle A here? So let me zoom in on that. So here I got 125. What do I get for angle A here? I don't care about B and C here because they'll basically fall out. It's basically like same thing. So but A here is what I'm focusing on. So let's we have 125 up top. I'll draw it in here. Okay. $55? Yes, that is the correct answer. Good. So one of the things I want to talk about here is why it's 55. I think that's I'm glad you mentioned that here. So the reason why this angle, let's call it angle A, is 55 is, remember, this is still a straight line. So even if it crosses over with something, it doesn't matter. This is still a straight line, which means it still forms a straight angle. So if I wanted to find A here, remember a straight angle here was 180 degrees. So technically to find angle A, we take 180, which would be the combination of this straight line, and just subtract off the 125 that we have up top. And that's where we end up with the 55 degrees. If you want to end up with, say we know this is 55 degrees, then we know by congruence this is 55 degrees over here. And this by default is 125 because it has to match the one up top. So again, that's why I don't focus on, like, say, B or C necessarily. Okay, so just letting you know, that's how I essentially get that done. Okay. Any questions about that? No. Just a second here. Why am I getting that phone call? Okay. Maybe, no. Okay. All right. Give me just a second, folks. I think I might have gotten an important phone call there, so I need to check outside for here just a second. I think they came at thought they were going to come in the evening, but they decided to come in the morning. Let me check that really quick. Be right back. Apologies about that. I was expecting a package and I thought it was going to come in the evening here, like when classes were over, but I'm like, oh, you called me. And I'm like, wait, why are you calling me? Shouldn't you guys come in the evening? So, anyway. All right. Panicking for nothing. All right. One of those packages you have to kind of receive by hand. All right. In any case, that's not very important now. Let me copy pasta that. Oh. Guess I'll just put it down here. Sure. All right. So we have that. There we are. Okay. So that's about angles there. It's really not too hard to figure out, at least with those guys. Again, I'm not gonna go over too hard on the angle stuff here. But now we need to talk about what the last part of this section here is going to talk what I want to discuss, and that is talking about degrees, minutes, and seconds. Okay. Let's discuss about degrees, minutes, and seconds next. Now, this is the first time the book talks about degrees, minutes, and seconds, okay? Now, degrees is something that we're all kind of familiar with. Again, um, like 55 degrees, as we just mentioned here, okay, or again, 73 degrees. Those things are pretty normal. Now, if you want to make a refinement here, though, to refine, more of to reflect, say, a decimal degree, to do that, we reflect it in degrees, minutes, and seconds instead. Now, how does it work? Well, let's go ahead and take a look here at our nice canvas, and we'll see how that works there. So. All right. Put it over here. Okay. Let's talk about the basics here behind degrees, minutes, and seconds. Okay. Now, first of all, what does degrees, minutes, and seconds look like here, at least in terms of an example? Example of what degrees, minutes, and seconds could look like here is, say, 37 degrees, again, just with the same notation as we were used to before. 44 minutes, again with the tick mark here representing minutes, and 36 seconds with the double tick mark here representing seconds. Okay, so this is what degrees, minutes, and seconds can easily look like, okay, in some form or fashion. Now, the important point here, of course, is to understand how we can manipulate things with degrees, minutes, and seconds, because certain problems here will ask you to, say, add or subtract with degrees, minutes, and seconds, all right? And so we're going to need to know how to do that here in this case, and that's why I'm taking a little bit of time here with this particular part. Now, for some reason here, they don't stress on it too hard in this section here, but like I said before, since we're going to be dealing with degrees in some capacity when it comes to like chapter 10 with trig, yeah, that's definitely going to be a thing. So, and because that's definitely a thing, we at least acknowledge it here in chapter 8, and then we'll come back to it once we start talking about chapter 10. So get a little bit of a head start on that, and then we'll see where we actually apply this later on. Okay. So 44 degrees here, 37 degrees, 44 minutes, and 36 seconds. Now, what we want to know is, what's the key here? The key here is to know a couple of conversions, okay? So let's talk about a couple of those conversions. The first thing is that if we it works like hours, minutes, and seconds. Okay, so if you think of degrees instead of hours, think of degrees put in its place. The only difference is that we don't have a 24-hour clock. We can have, well, as many degrees as we want. So Minutes and seconds, though, are limited to the same thing as time, okay? So that doesn't change, meaning to say, again, 60 minutes, like 60 minutes would be an hour here. Well, 60 minutes is now equal to 1 degree. So that's perfectly fine. All right. And of course, 60 seconds here, just like normal. 60 seconds is equal to 1 minute. All right. So we're going to use these two conversions here as the key in order to help us solve for these problems here for adding and subtracting and whatnot. Like I said, there's a little bit more to this, but we're not going to explore that yet until we get to chapter 10. Okay, right now we're just dealing with the super basics here for degrees, minutes, and seconds. So let's just start off slow. Okay, first, let's go ahead and talk about addition of, let's say, degrees, minutes, and seconds, okay? So let's see here. Sure. Okay, let's start off with addition here. So I'm just going to do an example here of adding two things with degrees, minutes, and seconds, and then we're just going to see what we get. So let's start off with 74 degrees, 80, boy, what am I doing 80? 80 makes no sense. 55 minutes, and 49 seconds. Okay. And then we're going to add that to 38 degrees. Let's see here. 43 minutes and I don't know, 17 seconds. So I'm just picking random numbers here. No rhyme or reason, but I'm just going to pick numbers here. Okay. So this is our two random, you know, random degrees, minutes, and seconds that I just chose. Fine. So what do we do here if we're going to add here in this case? Well, let's just add up the numbers straight up, okay? Just add them straight up. That's all I want you to do here for the first step. So the first step here, let's just add it straight up. So adding it straight up here, I'm gonna put this in black. So we have 49 plus 17, so that'll be 6 and 6. Okay, so 66 seconds. Again, we're just gonna kind of separate it off. So minutes go with minutes, seconds go with seconds, minutes go with minutes, and degrees go with degrees. So when I'm talking about adding straight up here, I'm just going to separate them off as their own respective thing. So I'm just going to add up the seconds here together. Let me add up the minutes here. I get 98 minutes. And then here I end up with 2, carry the 1, I get 112 degrees. So just adding it up here is what I'm doing here for my first step. Okay. Now, in our right mind, I again, this is where things should hopefully make sense. In conventional speak, if I ask you for the time, you say, "Oh, well, the time is 1:42." Like let's say, okay, the time right now is 10:38. All right, fine. But you're not going to tell me, "Oh, well, the time is 9:98." Like that makes you see that's a little awkward, right? Oh yeah, the time is 9:98. Like somebody will look at you like, what? Time is 9:98. That's kind of weird. As in that makes no sense. Yeah. So nobody's gonna say that. Of course not. So we're gonna want to of course change things appropriately, and we're gonna use our key here in order to help ourselves out in order to do that. So you want to say that, put it in a microwave like 9 minutes and 98 seconds in a microwave for like a meal or something. You're like, yeah, that's pretty weird, bro. Okay, so what we're going to do here first is we're now going to convert 66 seconds into minutes. Okay, so converting 66 seconds into minutes, we're just going to go ahead and split that up. Again, since we know 60 seconds is 1 minute, just split that up appropriately. That's going to be 1 minute and 6 seconds. Okay, so no big deal. There we go. We'll also take 98 minutes here. So 98 minutes needs to be split up in terms of degrees, and it needs to be split up in terms of degrees and minutes. So we could just subtract 60 off of this, and we get 1 degree and 38 minutes. Okay, so 1 degree, 38 minutes. Just subtract 60, and you'll be fine there. And we'll just keep the 112 the same because we're not doing anything with that. So 112 stays the same, exactly like so. And so all we're going to do here is just add these together, straight up. So we're going to take degrees with degrees, minutes with minutes, and seconds will be left over. So if we do that here in this case, we have 112 degrees plus another degree. That's going to be 113 degrees. 38 minutes plus another minute, so that'll be 39 minutes. And 6 seconds. Okay, so there's how we can go ahead and add degrees, minutes, and seconds there together, just like so. Are there any questions about that? No? Okay. So hopefully that made sense there. At the very least, that's the most important part. It should make sense. So, yeah, I just want to be sure to be like, I didn't understand anything you just said. Be like, yeah, I know that's about half the things I say. But you know, that's how it works. Okay. Okay. Now, that's addition. Let's talk about subtraction now. All right. Okay. So subtraction here is going to be a little bit different. Now, we're going to still use this key here for, 60 degrees, 60 minutes is equal to 1 degree and 60 seconds is 1 minute, that sort of thing. That's still going to be the same. Still going to use that key, but we're going to talk about the key here for subtraction specifically. Okay? And so let's go ahead and put that down. The key here is fairly simple. And we'll put that in red here again. All right, so the key here is basically to borrow. We're going to borrow we're going to borrow 1 degree or 1 minute. If we're going to do subtraction, we're going to borrow 1 minute, sorry, not 1 second. We're going to borrow 1 degree or 1 minute. And this will make sense once we do the problem out. Okay, because subtraction is noticeably a bit tougher than that of addition. Okay, so let's put down a random problem here, random numbers, okay, and we'll see what we get. So let's start off with, I don't know, 93 degrees, 17 minutes and 22 seconds. Okay. And we'll subtract that by 36 36 degrees, 42 minutes, and 53 seconds. So let's say we're just subtracting these from each other here, and we want to see what kind of answer that we get. Okay, now, here's the problem with this one. Although in the last problem when we did addition here, as you can see on the upper right-hand side, we just added straight down, with minutes and, seconds and minutes and degrees. That was okay, all right? That didn't go over so bad, because then we're just able to do an easy conversion there. Now in this case, though, doing 22 minus 53 is very, very awkward and makes things very, very hard. We want to avoid that as much as possible, is to make things as awkward as possible. So, we don't want to do that. 17 and 42, same deal, right? Not really all that great to go ahead and subtract. So we even further complicate things if we just decide to try and brute force our way through. 93-36, I think that's doable, but again, 2 out of 3. If it's already hard, then it's going to get harder if we keep going down the line. So that's where this key comes in. We're going to borrow 1 degree or borrow 1 minute. Because what we want in effect here is we want the top numbers there to be bigger than the bottom numbers that you see below. Because in that case, if the top numbers are bigger than the bottom numbers there that we do subtraction with, it's a lot easier to physically do subtraction with the top number being bigger and the bottom number being smaller. And that's exactly what we want to have happen. But of course, the consequence of doing that here is the key that you see there on the screen, which is to borrow 1 degree or borrowing 1 minute. So for example here, let's take a look at this example here. So 22 seconds is less than 53 seconds. I can't really do that. So I'm going to borrow 1 minute. So I'm going to borrow 1 minute from the next column over. So now this suddenly becomes 16 minutes because now I'm borrowing 1 minute. Now if I borrow 1 minute, we know that 1 minute is equal to 60 seconds. So now I'm just going to add 60 seconds here to this right here. Okay, and so what I have here so far is if I add 60 seconds here, all right, let me just go ahead and write this out here. So I'm going to have 93 degrees, 16 minutes, and 22 plus 60, and 82 seconds. So in this case, it's okay to have 82, okay, or whatever, because now I can do 82 minus 53. That is a lot more doable than doing 22 minus 53. And still, again, I'm just rewriting the problem here. I haven't actually done the subtraction yet, just to let you know. Okay, so nothing's happened here so far in terms of our, our actual subtraction. We haven't even done that yet, but we will in just a second. Just need to extend that out to get a little more room. Okay. Okay, now let's take a good look here at this next part. Now we're still not quite done just yet. Okay, reason being is because we have a 16 minutes and 42 seconds at 42 minutes. I can't take 16 minus 42. Again, I have 1 degree or 1 minute. That's what I'm going to borrow. So once again here, I'm going to borrow 1 degree. But again, if I borrow 1 degree, I know that 1 degree here is equal to 60 minutes. So I'm going to now take away 1. So now this becomes 92 degrees. And now I'm just going to add 60 here. I'm going to put that in blue. And so now, just rewriting the problem here. I haven't done the subtraction yet. I just need to rewrite it maybe a couple times so I can get it done. And here I'm going to get 76 minutes, 82 seconds. And I'll subtract 36 degrees, 42 minutes, and 53 seconds. Now, as you can see, every number on top is less than the numbers that you see there on the bottom. Now you could just line up seconds, minutes, and degrees. You can go ahead and subtract them straight up, and you're going to get your final answer based off of that. So what we see here is we have 82 seconds minus 53, that's going to be 29. We have 76 minus 42, that's going to be 34 minutes. And we have 92 minus 36 here, that's going to be 56 degrees. So that's our answer here. Our answer is 56 degrees, 34 minutes, and 29 seconds. Okay. So that's how we do some subtraction there, is we just do a little bit of rewriting, basically borrowing either 1 degree or borrowing 1 minute. Are there any questions about that? Nope. Nope. All right. Cool. Hopefully that makes it a tad bit easier to do. That's the hope anyway. But all right, there we go. Got it. Okay. Okay, so that's degrees, minutes, and seconds in a nutshell. All right, let's go ahead and take a look back at the book here really quick. So I'm going to go back to the book here. And I want to do just one of these problems here. I'm not going to stress too much on a lot of these. A lot of these say, oh, you use a protractor and blah, blah, blah. Again, actually in the section here, there's not a lot. I know that we spent a lot of time with this, but again, a lot of that what we discussed here is pretty much setting ourselves up for chapter 10. So that's what this section really is about. Most of this is just like use a protractor. I'm not asking you to use a protractor because more than likely you're not going to be using protractors. You're going to be using optical comparators if you're going to be using it in an actual setting. Anyway, I digress. Let's look at number 13 here. That's the only one that I really care about in this particular section. So 13, welding. In the pipe flange shown, the 6 bolt holes are equally spaced. What is the spacing of the holes in degrees? What do you think, guys? What's the answer to this question? This one is more of a conceptual question more than it is the math question. Math question part is not terribly hard, but the concept to get it is important though. What do you guys think here? What's the spacing of these holes here? There's 6 bolt holes equally spaced. All right, really quick. What shape is this particular pipe flange? What's the generic shape? We don't know what the shape of this flange is? Okay. Well, the shape is definitely a circle, and I agree with Brenton here. 360 degrees would be the angle measure here of a complete circle. But now you have 6 bolt holes that are equally spaced. All right? So what would be your degree measure between each of these holes? So 360 is the hard part. I agree with that, Brenton. All you have to do is one more step here to get your answer. Okay, so what's 360 divided by 6? Totally agree with you, buddy. 100%. 60. All right, that's correct. The answer for this question here, 100%, is 60 degrees. That's right. 360 degrees for the circle. There's 6 equally spaced holes. 360 divided by 6, 60 degrees, spot on. Nice job. All right. So that's the only one that really matters here. The rest of them are just like meh. All right, so like yeah, they're there. Anyway, let's move on. Okay. That's essentially section 8.1. Not a whole lot going on there. All right. Okay. Next. Let's talk about the next section here. Okay. So the next one we're going to do here is section 8.2. Okay, and we're going to talk about perimeter and area of polygons. Okay. All right. So one thing that is important here in this section is, of course, we will need to talk about perimeter and area of polygons. Now, in this case here, this is only going to be specifically for 2D shapes. Okay. So all right. In the next chapter here, in chapter 9, we'll talk about 3D shapes. But in this case here, we're just talking 2D shapes, so just an up-top approach, and that shouldn't be too hard. Okay. So let's first talk about what perimeter is. Okay. So perimeter here is specifically the sum of all the outside lengths of the polygon. Okay, so all you have to do is take all the lengths of the outside, add them up all together, and then there you go. That's perimeter. Easy peasy, lemon squeezy. All right, so for example here, you could have like, let's see, I'll just make a 2D shape here. So let's say we have a rectangle that looks like this. Okay, we have, again, we have our length here of our, and we have our width over here. So there's our length, there's our width. This is a length, this is a width. If we want to find the perimeter here of a rectangle, okay, perimeter here is equal to 2L plus 2W. There's L plus L, which is 2L, and W plus W, which is 2W. Add them together, you got a winner chicken dinner. That's where it is for, it's pretty predictable for a rectangle. Other things may not be as predictable because, again, it just depends on what those sides are. If you have a if you have like a 5-sided polygon, then maybe you gotta actually do that there. Do I only teach Math 097? No, of course not. You just usually catch me when I'm doing Math 097. Today I have 097 for 2 classes, but I have a Math 101 class in between. I also teach pre-algebra and college algebra. So, but I've taught any class between pre-algebra to calculus 1. So that's my bread and butter there, Andy. Yeah, so I can cover a wide variety of topics. We could talk about statistics, that's fine. Business calculus, okay. So higher level stuff, pre-calculus. Sure, no problem. Just trigonometry? All right. Okay. That's about perimeter there. Okay. Let's talk about a couple of other things though that are important. Okay. What we want to talk about here, besides perimeter, of course, is let's look at the other side of things because there's a second thing we do need to discuss here. So the other thing that we'll need to discuss here is we need to talk about area. Perimeter by itself is very easy, but area is, again, it depends on the shape that you're given. That'll tell us what the area of that particular 2D polygon is going to be. Okay, so let's take a look here at area specifically. All right, so we're going to look at various 2D shapes here, and we'll take a look at the area for each one of those, okay? And hopefully that won't be too bad. So may have to draw some in because I don't think this little guy has all of them, unfortunately. So okay. So again, this is our length, this is our width. If we want to find the area here of a rectangle, get an area, rectangle has all four right angles here. The area here is going to be equal to length times the width. Okay, so the length times the width here is going to be the area of a rectangle. All right. Remember that squares are rectangles. They're just very special. They just have the same equal length. So, but if you want to see like for a square here, in a good old square, there's a pretty nice looking square. So square here has a side here. Let's call it S. Here's a side here. The area of a square here is equal to S times S. Again, same thing as length times width, or S squared if we use notation there. All right. So that's about a square there. Again, a square is a special rectangle. That's basically what it is. No problemo. All right, let's see if I can manipulate this square here. If not, I'll just draw it in, which is okay. I don't think I'll be able to do that, sadly. Nope. Okay. Guess I'll have to draw it in then. Looking at my options, but I don't have many, so that's fine. So the next one here is going to be a parallelogram. So it's kind of like again, a slanted rectangle of some variety. Okay. Now what we have here for a parallelogram is that for this, you could have a base. All right. So I just messed that up. You know what? I think I'll just type it up. It's so hard to type out, to write out long words. Okay. All right. There. So what we have here is a base B. Then from this base B, we actually have a height. This height here is from here all the way down. So this is height H. So the area here in this case is equal to base times height. Okay, so B times H, or base times height. Perfect. Okay, let's look at another one. Let's see here. That's the only other one I want to do here. Okay. So the last one here that we can look at in this case here for these type of polygons are going to be, last one here will be a trapezoid. All right, so we have a big base and we have a small base here. You just rewrite that. Small base. And then we have a height h here. Okay. So what's the area here in this case? Well, the area here specifically is going to look like this. And this time I am going to type this in because it requires a little bit more than what I have. So the area here specifically is equal to, that doesn't look like that, a bit more. There we go, that's better. So this equals to 1/2 times the big base plus the small base. Again, we add those together there. And then multiply that by the height. So 1/2 times the big base plus the small base times the height here is the area of a trapezoid. Okay, so that's what we have there that we'll certainly use. Okay, so now that we have all the formulas that you can see up here, and I'll go ahead and copy this over to the thing. So okay, so now that we have that there, let's go ahead and reference this here. I actually do want to save this. Give me a second here. There we go. All right. Okay, so let's go ahead and take a look at a couple of examples here. All right, and we'll see exactly how this will work out. Now, these examples will be the word problems here from our section. So again, we'll have this little reference thing handy here. So let me go to that page. Page 558. All right. Okay. Let's see, which one would be okay? Ah, yes. Okay, let's do that one. All right. Let's take a good look here at number 1. All right, masonry problem here. All right. All right, so how many bricks will it take to build the wall shown if each brick measures 4¼ inches by 8¾ inches, including mortar, and to change the wall dimensions to inches? Okay, so in this case here, we want to build a rather long and extensive wall, pretty high as well, 7 feet 1 inch. All right. Now, we want to figure out how many bricks that will take, given the dimensions of each brick with the mortar put in place. How many of that do we need in order to put that together? Okay, let's go ahead and find out. All right. So, in order for us to do this problem here, we need to convert the dimensions of the wall here into inches. Again, the reason why we want to do that here is because all the bricks are measured in inches. So again, this is one of those classic examples where context definitely matters. And this is where you need to be very careful in problems like these. because it says 35 feet, not 35 inches. Okay, or it doesn't say that at all. So we want to be very, very careful about that. Most definitely. Okay, so let's look at 35 feet. All right, what's 35 feet in inches? It's 35 feet in inches there. It's off to the side here. What's 35 feet in inches? How do we convert inches into feet? Or feet into inches, sorry. Other way around. How does that go? What do we do? Hmm. All right, 35 times 12. Very good. What's 35 times 12 here then? Totally agree. That's right. 1 foot equals 12 inches. Correct. So what do we get here? 35 times 12 is? 420. All right, so 420 feet. So right now, as it stands, we have a brick wall. This is 420 inches across. How about 7'1"? What's 7'1" in terms of inches? How many inches is that? Stop calling. Why do you call me 17,000 times a day? Holy crap, man. 85 inches. All right. Now, correct. Okay, good. 85 inches, not too bad. Again, just do 7 times 12 plus 1. There you go. Yeah, I know what you meant there. You're good, Bren. You're good, buddy. Okay. 85 is spot on. All right. So these are the dimensions of the wall, right? We have a 420. We have a blazing wall here of 420 inches across and 85 wide. All right, now we need to find out how many bricks, okay, how many bricks it's going to take in order for us to go ahead and put that, basically make this wall here. So, how do we do that? How are we going to find how many bricks it's going to take for us to uh, see how many bricks it'll take to complete the wall? All right, agreed. 85 and 420. All right, and what do we get here? 85 times 420 will net us the area for the wall. That part is definitely true. So 85 and 420, what do we get? It's 85 times 420 there. All I just need is an answer for this. $35.7. All right, good. 35,700 is correct. Okay. So since we have 35,700, now, completely agree with that here. So this is how many square inches this wall has to be. All right, that's fine. Now, what we're given here is that we're given the fact that each brick is 4¼ by 8¾ inches. Now, if it helps, what we can do here specifically is to make this a tad bit easier. Remember that 4¼ here, and I'm going to erase that part because I need space. Sucks not having a lot of space. Ah, no. Why? Why must you do things that are against what I want? Okay. Just need a little more space here. All right. So what we're going to do here is, since every brick, as you can see, is 4¼ by 8¾ we're just going to convert the brick into its its decimal counterpart. So we're going to have 4.25, sorry, times 8.75. Okay, a quarter is 0.25, 3/4 is 0.75. So if we multiply these together here, what do we get for the area of one brick? We got there 4.25 times 8.75. Should be strictly calculator time here. What do we got here, ladies and gentlemen? Oh my. $37. Okay, good. All right, spot on. Good beans. All right, so 37.0125. Okay, now what we're going to do next is we're going to take that 35. We're going to take that 35,700. Okay, since that's going to be the amount of square inches that this wall needs to take up. And we're just going to divide it straight up by the 37.0125. And let's get an answer for that right now. Okay, so you get 9,000. Get 9,000 there. Okay, that's fair. So let's round that up. Brenton. So if we round that up there, so I agree with your exact answer there, but yeah, we want to round up here because then we have just that enough bricks in order to fill out the whole wall. So completely agree here. So round up so that way we make sure that we have just enough. So that's going to be 96.59 would be our answer there. It wouldn't matter what we get here. Did we accidentally mess that up? Let's see. 1875? You guys, I'm kind of relying on you. Oh, okay. Well, then let's do that then. Sorry about that. But what do we get for that then? If this is 1875. It's rather important there. Change that. Process is still the same, just the numbers may be different. I haven't used my calculator, so it's pretty easy if I did. But okay, so wait. Okay. So if we divide that, now I'll go ahead and use this here. It's a lot of bricks. Darn right, just darn right it is a lot of bricks, my dude. Get 960 for that? How you been? How you doing, Toby? Oh yeah, 960. There we go. I'm gonna say I'm like that's a lot of bricks, bro. I hope you're doing well today, Toby. Hopefully your weekend went good too. I know you're still resting up and stuff, so getting back into fitness and whatnot. Yeah, I'm feeling thanks Toby for asking. Yeah, I'm feeling better. I just needed a day to kind of like my allergies were just flaring up a lot and then I was just kind of like it's kind of felt like meh. By the end of the night I started feeling a bit better. My eyes aren't as watery. I think that things are getting colder here in the Chicago area, so starting to finally turn into winter over here. So took a while though, to be honest. So that's kind of like what's been going down there. 960. Okay, 960 makes sense. All right, that's fine. Brenton, I think you accidentally not only used the wrong number, I think you accidentally put 33.718. I think that's what happened there. But that's okay, buddy. You're all good with me. How about you? Toby, is your hamstring feeling better? I believe that was your injury there. You back to 100%. Hey man, that's legit, my friend. That's legit. That's the difference between you and I. You could get back to fitness 100% despite pulling a hammy. The only difference between you and I is you pull hams. You pull hams. In your leg. I just pull hams out of a grocer's freezer. That's the only. Like the legit person here is you, not me. I'm too lazy. uh, but that's awesome, dude. I'm so glad you're back to 100%, you man. I know it's been, I know it's been kind of up and down for you, but you know what? Hey man, I'm just gonna say this. You got talent there. Definitely got talent, and it's gonna shine through. It's gonna shine through. Trust me on that. Sometimes there's a lot of roadblocks in the way or stumbling blocks, but Don't let that discourage you, my friend. Don't let it discourage you at any time. That's a question for you, Toby. I actually do have a legitimate question there. Oh, it's okay. Hey, Brenton, don't worry about it, buddy. It's not a big deal. That was me being kind of relying on you guys as well. So I'll take most of the blame for that. That's not a problem. I'll take half of it if you want, but I'll definitely take a portion. All right, let's try another here though. Let's see. Just one more here should be fine for this one. So, where is it here? That's for the concrete box there. Let's see, which one do I want to do? Okay, I think I know which one I want to do. That's for, yeah, perfect. I'm going to do that one. All right. Just want to pick the right one here. Okay, let's go ahead and take a look at number 17 here. Okay, 17 is an agricultural question. Fertilizer must be applied to the planted area shown in the figure. If each bag covers 300 square feet, how many bags are needed? Be careful of units. Okay, so let's be a little bit aware about units here. Now, each bag is going to cover 300 square feet. However, take a look at problem 17 here. Problem 17 is in terms of yards for each one of our dimensions. Now, to be fair, well, we're going to go ahead and figure out what the area is in terms of yards first, and then we'll go ahead and factor that in with each bag covers 300 square feet. So shouldn't have a problem there. Okay, so let's go ahead and talk about again the area of a trapezoid. So the area of a trapezoid here, once again, let's go back to our paint tool here. Like, do you have like an automatic camera? Like that's the question. That's my question to you, Toby. Like, do you guys have an automatic camera that records every game? I'll ask Stampy. That's not a problem. But just you know. Hey, Jen. No problem, my dude. Absolutely. Absolutely. You go enjoy Shari's stream, man. Shari's really good. Did Shari get out of his cast today? I sure hope he did, man. He's been wearing that forever. This is no fun. All right, so what we're going to do here is we're going to find the area of this trapezoid here for number 17. Am I muted? No, I'm perfectly fine. Oh. I don't know, but am I muted? I should be okay. Ah, okay. No problem, no problem, no problem, no problem. It's all good, buddy. It's all good. No, I'm glad that no, it's all good, buddy. You're fine, you're fine. No, go out and enjoy Shari. You know, Shari's getting his cast off this week at least. At least from what we were told, so it's perfectly fine. So let's take the area of a trapezoid here. 1/2 times the big base plus the small base. Times the height. Hey, that's the least I can do, man. I mean, look, yeah, I know I'm gifting subs there, but really it's about your involvement with the community there, Jan. Okay, so when you involve yourself in the community with hashtag, you know, you're supporting the club not only with your enthusiasm, but hopefully you'll be a supporter for life. And you'll come out and maybe you'll make your way out to a few games in the future. Once games start up after this lockdown stuff. And I know the support that you give to them is greatly appreciated. I may be a facilitator of that, but you know what? It's your support that means a whole lot more. I can trust me on that. I just want you to know, keep sending out those positive vibes, okay? All right. So let's go ahead and take a look here at the area of this trapezoid. So the area of this trapezoid here we have the big base of this trapezoid, which is 39. That's the big base. The small base is here, it's the one up top. That's going to be 19. And then we're given the height here, which is going to be 16. So one thing to take to the bank here in this case is that the 21 on the side and the 17 on the side, they don't really mean a whole lot here in a problem like this if we want to find the area of this particular trapezoid. The only thing that matters is these three numbers here, the 39, the 19, and the 16 here respectively. Okay, we'll just move that over just a little bit. All right, so let's go ahead and multiply that on our calculator here. So we got 39 plus 19 here first, multiply it by the 16, and then just divide that by 2, and you should get 464. Now remember, this is 464 square yards, okay? Not square feet. Remember that each bag of fertilizer covers 300 square feet, okay? 300 square feet, not 300 square yards. All right, so we're going to need to be careful about how we want to conduct the rest of the problem. So what we want to do here first actually is to convert this 464 square yards into square feet, okay? Now, in order for us to do that here specifically, we just need to use a conversion. Our conversion here is we have 1 square yard is equal to 9 square feet. So 1 square yard is equal to 9 square feet. So if that's true, okay, can you tell me here, how many square feet of space do we have? What should we do? How do we find the number of square feet here in this case? I am going to use this conversion here. 1 square yard equals 9 square feet. So Yeah, multiply 9 times the 464. Wonderful. So let's multiply 9 times 464. What do we get there? 9 times 464 is... I think we get, like, what? 4,176. All right, sounds good. All right, 4,000. Yeah, it is definitely 4176. You got it, buddy. Yes. All right. Yes, sir. Yes, sir, indeed. All right. So now what we're going to do is we're going to take the 4176, since that's the number of square feet that this particular area is. We're going to divide that by, what is it again? 300. We're going to divide that by 300, since it's 300 square feet per bag. Okay. And we're going to get a decimal here for sure. But can anybody tell me what we get here? All right, good. Now I want you to round that up there, Brenton. Okay, so you got that? That's okay. That's correct there. Okay, so round that up, because we can't buy 0.92 of a bag. We can only buy whole bags of fertilizer. So yeah, round that up to 14. There you go. That's correct. Good. So 14 bags there, because again, that just goes back to what we talked about before when we talked about certain word problems. Since we can only buy whole bags of fertilizer, then if that was even 13.4, we'd still round up there to 14 bags. So uh, in order to get the job done. All right, really good, really nice, nice work. All right, so that in a sense is section 8.2. Hopefully that's not too bad. All right. Any questions so far? I'm gonna go ahead and put this down. There we go. Save that. All right. Let's go to the last section here. Now, again, just as a friendly reminder to you guys, all right, remember, we are skipping section 8.3, okay? So section 8.3 will not be talked about here. So we're going to go to the last section here in chapter 8, okay? And we're going to go right into it. Okay, so the last section here in chapter 8 should be something that you guys have worked with before. So it shouldn't be anything brand new to any... Jeez. Well, okay, esophagus, why don't you tell me what to do? Let's look at section 8.4 here, which talks about circles, okay? So you guys have seen circles a bazillion times, okay? So what I'm going to talk about here isn't going to be brand new, but it is going to be looked at here in terms of our two different things that we talked about in the last section. Because last section we talked about perimeter, we talked about area, okay? And we want to talk about those same two things here when it comes to circles as well. Okay, so let's go ahead and take a look here about circles, about area of a circle, the perimeter of a circle, that sort of thing. So let's go back to our paint tool here, and let's go ahead and remove all this junk. Bye. All right, fresh and clean. All right. Alrighty. So circles aren't anything new to anybody sitting in this room right now. I think everybody's dealt with circles at least at some point. Okay, so here's a circle here. Let's make it super big. There's a circle. Yeah. All right. Now, one thing about a circle is that there are two parts of a circle. So let's at least identify that. Here from the edge to edge of a circle. So if we go, let's say we have a center of the circle here. Let's say that center is right here, smack dab in the middle. Okay, so let's say we have this. This is the center of the circle, and we have a line that goes through that center of a circle, straight on through. That, of course, this represents here what we call D, a diameter. Okay, so we'll have D here. D here represents the diameter. Okay, a full length all the way through. Spelling is not one of my things today. I don't know what's going on. All right. Let me know when spelling gets to be my thing. I'll let you know. Uh, spelling is like, all right. I'm a whole lot of poop, man. Whole lot of bad. All right. Anyway, then, all right. Then we have this. All right, from the center of the circle that goes halfway through. All right. So this is going to be labeled as R, and R here is going to be our radius. Okay. Now, one of the important things regarding circles here, at the very least, is we want to reflect the diameter and radius here appropriately. So I'm going to make this a bit bigger here. So I will make this 36. Okay, first and foremost here is that, why? Hang on a sec. Why are you giving me the business here? Oh, now you give me the business. You suck. All right. Alrighty. Anyway. Oops. So diameter here is equal to 2 times the radius. All right, so 2 times the radius is equal to the diameter. More importantly, though, if we're given the radius here in a problem, then of course the radius here is equal to the diameter divided by 2. Okay, so we could just go the other way around as well. That's really not too much of a problem. So the one that we want to use here majority of the time is we want to use radius is equal to diameter divided by 2 if we're given that. Because a lot of the formulas here do require either one or both. It just depends. So I prefer to use radius because radius is usually the most relevant for a lot of applications. But you go with what you're comfortable with. I prefer radius though because that's the easiest one to figure out. Okay. In any case, let's take a good look here at the perimeter. Now, the perimeter of a circle here is just all the way around on the outside. Although we don't call it perimeter for whatever reason because we have to make things harder. Instead, we're going to call that circumference. Okay, so circumference. So circumference, I'll put in parentheses here, perimeter. So just a perimeter of a circle or circumference, whichever way you want to call it here. So circumference here is equal to pi times the diameter. So if you're fine with that, you can use that. Or since diameter can be reflected as 2 times the radius, 2 pi r. So 2 pi r or pi times diameter there, those are both okay to use. No problemo. Easy peasy. Lemon the squeezy. All right. Let's also talk about the area of a circle here. I'm going to state that right away. So the area of a circle here is going to equal either one of two things, all right? And that's going to be equal to pi r squared, okay? So pi r squared is one thing, or pi times the diameter squared over 4. Again, that's because radius can be reflected as diameter divided by 2. Again, I'm not a big fan of the second one. Obviously, it looks a lot more messy to use, and I'm not going to disagree with that. This is a good reason why I like using radius over diameter. It's just like you don't really have to divide by 4, think more, think more things. It's like, okay, let's just plop in the radius and we're done. Like, okay. It's like, yeah, all right, that's not too hard. Okay. Well, fine then, Great. We'll do that. Okay. Now, let's take a good look here and let's see how we can go ahead and apply these in an appropriate way, depending on the problem that we're given. All right. Let's look at, I'm going to do some word problems here, of course. So let's take a good look here at this page. So let's look at number 6, okay? Number 6 here. All right. So I like this problem here because it kind of tests a lot of the things that we're going to be doing here in this section. So this is a very, very good problem here to kind of cover. All right. Okay, good. That should be fine. All right. Do 2 problems from this section and we're good to go. All right. So machine trades. In a piece of steel shown in the figure, 4.5-inch diameter holes are drilled in a 22-inch diameter circular plate. Find the area remaining. Okay, so here we have this circular plate. It's 22 inches in diameter. Okay, and we've drilled 4.5-inch diameter holes, 4 of these specifically, as you can see in the picture. And we want to figure out how much of the area is remaining after we after we drill these holes in. Okay, so let's think about it this way. How are we going to tackle this problem? What do you think is a good idea here? Because as it stands, it's kind of, let's think of it from a simple perspective, okay? Think of it from a simple perspective. In order for us to figure out whatever area is left over. What's the easiest way to kind of approach this problem? What's the easiest way to approach this problem, you think? Let's just at least reason it out, How are we going to approach this problem here? Why are you still calling me? This. Right. First 4.5 inches holes times the 22-inch diameter? No, I don't think I want to do that there. Think of it from a much more simple perspective. If we're, I'm not even thinking about numbers here. Think of that as a super simple perspective here. I want to figure out how much in that, kind of bluish portion is left. Okay, that's what I want to do, right? So if I'm just thinking about, forget the numbers for a second here. Forget the numbers. If I want to figure out how much of that area is left, okay, just on a basic perspective, wouldn't I just take the area of the whole disk, right? If I took the area of the whole disk there and subtracted out the area of the holes that I put into that disk, right? I'm just going to look at it that way. I'm going to say, okay, I got the area of this whole metal piece, and I'm going to just subtract that out by I'm just going to go ahead and subtract it out just straight up by whatever I drilled out. Does that make sense? That's all I'm going to look at here. I just want to keep it as super simple as possible. All right. So basically what I'm looking at here is this. I'm like the area. So basically, I want to find the area of the big circle minus the area of all the holes. This is all. Okay, so the area of the big circle okay. Now, that's the part we have to be careful about, Breton. Now, 22 inches is the diameter of this particular circle. But remember what's written up here, okay? So be very careful about this. It's the area here, okay? We want to find the area of each part. That's what we need to do here. Now, one part that I do agree with that, of what you've written down there, Brendan, is definitely the 4. The 4 is definitely something that we are going to definitely incorporate. I don't disagree with that. Okay, so the times 4 there, we're going to definitely come back and take a look at that there. Well, what we want to look at here specifically is we want to go ahead and take a look here specifically at each one of, again, let's take a look at the area of the whole circle here using our area formula here. Now, since this is 22 inches, that's the diameter here is 22. That means our radius here is equal to 22 divided by 2, which is 11. So what we're going to do here is we have our area of the big circle, or again, our big piece here. That's going to be pi times 11 squared. That's going to be our first part here as part of that problem. We have to use the area formula here for this. Now we also need to incorporate the area of all the holes drilled out. Well, now I have 4 of those holes. That part is true. So that's the part that I'm definitely going to agree with you there, Brendan. Got the 4 times something. Completely true. Now we just need to see what was the shape of the ear. We had 4.5 inch diameter holes. So for the holes here, they're 4.5 was the diameter. So for the radius here, that's going to be 4.5. Oh, maybe it'd be helpful if I move that. 4.5 divided by 2, which is equal to 2.25. And so here we're going to add 2.25. Have pi r squared, so we're going to have 2.25 times pi. There we go, just like so. And now we're just going to plug this into the calculator. Okay, so we're just going to plug this into the calculator here. Again, we got pi times 11 squared minus 4 times 2.25 squared times pi. All right, let me know what you got there. Let me know what you got. $247. But try that again. Remember to enter in all the numbers here. So you have to have pi times 11 squared or do 11 squared times pi, minus 4 times 2.25 squared, so you got to do that exponent first, and then multiply that by pi. Try that one more time on your calculator there, Brenton. You will get a decimal here for sure. So all right, very good. That's 351? Oh, whoops. 351. Let me check that there. 351. 351. What did I get? Not quite, my dude. Make sure you're writing this correctly, okay? Again, don't forget to use parentheses, by the way. So use the parentheses where I've used these parentheses. Like I said, don't skip steps. Want to be sure that you can replicate what I got up here. Let me know what you got there, Brenton, once you got that put together. There we go. That's correct. Very good. Very good. That is absolutely correct. Nice. All right. 316.5155. And we'll put that in square inches there. All right. Perfect. All right. Good job, buddy. Good job. Gotta get that calculator stuff down. Good thing we take our time with that. All right. Excelente. Very good. Very good. Very good. Okay. So far, so bueno. All right, let's do one more problem here, and then we're going to be done here for the day. All right, let's take a good look here at number 17, carpentry. The circular saw shown in the figure has a diameter of 18 centimeters and 22 teeth. What is the spacing between teeth? Okay, so each one of the tooths on this particular circular saw is evenly spaced out. All right, so we have 22 of these teeth here on this particular saw. Now, the one thing that we'll need to do here is, in this case, and the reason why I want to point out number 17, is in this case, we do not want to find the area of this saw. Okay, that's not what we're trying to do. Finding the area of this saw doesn't really make a whole lot of sense. What does matter, though, is that we can find the circumference, aka the perimeter of this circular saw, and then figure out what the spacing between each one of those teeth in this saw is going to be. Okay, so let's figure out the perimeter of the thing here. So the copy pasta this a bit. Hey, you know what? What am I doing? What am I doing? All right, I'm gonna do that. Let me copy pasta this whole thing here first. All right. Okay, so let's use our circumference formula here, which is pi times the diameter here. So let's take a good look here at our problem. Okay, so according to our problem here, our diameter is 18 centimeters. Okay, so 18 centimeters. So we're going to take 18 times pi here. Let's move that there. All right, there we go. So according to that problem for number 17, our diameter here is equal to 18. Let's find the circumference. So that's going to be pi times diameter here, or again, a equals to 18 times pi. Okay. Now what we're going to do here in this case is we're going to take 18 times pi, and since we have 22 teeth here in particular, we're going to take that 18 times pi, and we're going to divide that by 22. And then that should get us the distance between each one of those teeth there. It's much the same as like the word problem error in the first section, okay? Where instead of degrees, though, we're actually figuring out the actual circumference. All right, so let's put that in our calculator there. And let's go out to a couple decimal places here. All right, so what do you get here? 18 pi divided by 22. What do we get here? 18 pi divided by 22. $2.57. That is correct, Brendan. Nice. All right, great. So 2.57 centimeters is the difference between each one of these teeth. Nice. Okay. Great job. All right. Any questions about any of that? No? Okay, perfect. All right. So that's where we're going to leave off here for today. All right. That takes care of chapter 8, okay, for today. So for next week, remember we are not meeting on Wednesday, but for next week, next Monday, we are going to start with chapter 9. Hopefully, get done with that. All right. Okay. I want to thank everybody for coming out to the stream here once again. There's a lot of special guests who popped in, which is very kind. I want to thank everybody here again for popping into the stream. Okay. Wonderful stuff indeed. All right. Really, really appreciate you guys. Again, I want to wish everyone a very happy and wonderful Thanksgiving. I know that you may not be able to spend it with all your loved ones here, but I want you to know that at least online here, you definitely have people who care. I definitely do. Want you to make sure that you're not alone here on this Thanksgiving holiday. I'll be there with you in spirit as much as I humanly possibly can. Um, but with those and you and your family, please enjoy yourselves. I hope you have a nice meal. I hope you have a nice time just chatting away. And rest assured that hopefully, this crisis is going to get done, and hopefully, that drug will get approved. We should be hopefully good to go. Um, that's my best hope. So again, there you go. Got it. Can I email the notes? Absolutely not. I have been copying and pasting for absolutely no reason. Okay. I'm not giving you anything, Brenton. Forget it. Nothing. Nada. Zip. Zilch. Of course, of course. Of course you get the notes, man. Naturally, you're going to get the notes. I'm going to send it to you right now. That's what I'm going to do. I'm not going to. I ain't going to wait. I'm just going to send it to you right now. Hey, you know. This guy got you scared there. You're like, oh my god, he's not gonna let us. Like, yeah. Man, that's right. That's what I'm gonna do. Bretton, my whole goal this whole semester was just to spite you and leave you out in the cold. Okay, that was my. Yeah, no problem, dude. It was all out of spite, though. I'm just gonna point it out there. Okay, I sent it out of spite and spite only. Nah, man. Yeah, I'm glad it helps. I'm glad it helps. Legitimately, I'm definitely glad it helps. Because you look. Hey, all teachers are there to. All teachers there are there to crap on you all the time, man. Yeah. uh, we all been through the struggle bus. Totally, totally understand that. So, yeah, I just hope it helps. That's all I hope it helps. So, go that little extra. That's all good. All right. All right, everybody. Have yourself a wonderful week, a wonderful holiday. All right. And yeah, my next class is what, an hour? Yeah, about an hour. So, okay. Take care of yourselves, everybody, and we will see you all next week. Take care of yourselves, everybody. Have a wonderful day.